regulatory steps. You know, what are the regulatory steps? What are these key enzymes, right? So from each pathway, you know, what were they? And you know, and I've told you when we've discussed these that there are all these different layers of regulation. It's pretty complex, right? All these different allosteric effectors. I don't know what they are. I can't remember them, and I don't. You know, I'm not really that interested in knowing. I just want to know. There's actually one question that says, you know, what would logically regulate? So I'm not even expecting you to have memorized what they are. It's just from your choices, which ones are logical. They're the ones that do. There is an answer in there. They're the ones that do it. But okay, so I mean, what you know, we understand this logical business about, you know, is it needing to activate or feedback inhibit, right? So if you know what that enzyme is doing, that T regulatory enzyme is doing, you know, in what pathway, then it'll be obvious to you, okay? So what else? Okay, along those lines, there is one question that is, yeah, I have a little guilty conscience about it. It's just to reward those people that did study, just, you know, that had no life. You know, it was just to throw them 2 guaranteed points, but I do feel a little bad about it. So let's go over it so that everybody can get it. So I can have a clear conscience. So some of these key regulatory steps then, these key regulatory enzymes are regulated by phosphorylation, right? So let's go down the list, like starting just chronologically through the lectures. So the first one, glycolysis. Anybody remember which one that was? Pyruvate kinase, right? Okay, so we got pyruvate kinase, and then okay, so then as we're going into the TCA cycle, dehydrogenase, right? It's also gets switched on and off through phosphorylation. The next one that we encountered, I guess, wasn't until glycogen. No. See, and that's that's exactly how you should study, right? So okay, what are the so Logan was saying there's one in the TCA cycle, but no, right? So what are the two? There's 2 steps. Don't even tell me what they are. Just what kind of steps are they? Dehydrogenases, right? So there's 2 steps that are regulated in the TCA cycle, dehydrogenases, and it's not by phosphorylation, okay? So, okay. And so then I think the next one we encounter is phosphorylase, isn't it? Yes. Right? And it goes from unphosphorylated to phosphorylated, and then we later met one. What's the next one we met? Synthase, right? And so what do we know? What do we wake up in the middle of the night and know about the relationship of those 2 enzymes? The one that's breaking it down and the one that's making it. What's their relationship? They're reciprocal, right? And how were those things phosphorylated? They were phosphorylated by the same protein kinase A, right? The cyclic AMP dependent, right? All came down the same cascade. They both got phosphorylated, right? And it's reciprocal. And what do we know? What's sort of our, what we know? We know glycogen phosphorylase B becomes glycogen phosphorylase A, right? Because it's active. So B inactive becomes A active through phosphorylation, right? We know that, right? That's something we know and understand. So that means, what does that mean then about the synthase? When it gets phosphorylated, does it get activated? No, it gets inactivated, okay? So we got the activated, the inactivated. Oh, I skipped over acetyl-CoA carboxylase, or left it out, so that would be the next one, acetyl-CoA carboxylase. So we have the two that we understand whether they get the effects of phosphorylation. And then we have these others, so pyruvate kinase, pyruvate dehydrogenase, acetyl-CoA carboxylase. So turns out all three of those are like the synthase. When they get phosphorylated, they're all inactivated. So that means all of these that we've encountered, the only one that gets activated is phosphorylase when it becomes A. Okay? So, yeah, so there's the question. So really, but all you have to remember, I guess from that are two things. You already knew them. That phosphorylase and synthase were reciprocal. That when phosphorylase got phosphorylated, it was activated, right? You all already knew that when you walked in here, right? And so the new news is that all the other ones, we went down that laundry list, they're like the synthase. So it means in all cases that we've encountered, there's only one, it's activation. All right? So, you know, that's learning and understanding. That's not so much memorizing, really. So you see how you kind of have to use a little bit of logic from what you know to find your way without having, you know, if you want, you can make a table and put, you know, activated, inhibited, and but this way I think everybody right now understands how those are done. Okay, so Logan brought up these non-covalent regulatory steps. So then we skipped over a key one from glycolysis, didn't we? Fructokinase, right? And so there were multiple elements. I think citrate regulated it, but what's the feature that's kind of astounding about it, and was you know, we went over it a couple of times. What aspect of that regulation is kind of counterintuitive? Well, there's 2,6, yeah. That's just so weird. I just don't even like to. I think we're gonna revisit that with this. There's an integration of metabolism one that I'm gonna kind of build up and hit on that. But what else about phosphofructokinase?
It requires ATP, but ATP inhibits it.
Exactly right. And so because it,
It requires ATP, but ATP inhibits it.
Right. Remember that graph where at increasing concentrations, so at low concentrations, it's just a typical logarithmic function, but then you had this negative cooperativity at higher, right? So, yeah, and so if it's doing that, then is that competitive inhibition at the active side?
Allosteric.
It's allosteric at another place, right?
He said that yesterday.
So ATP can bind to phosphofructokinase at two places, and at higher concentrations it's binding to the allosteric site and shutting it down. Okay? So I think that pretty much covers, is there any other regulation? I think that's a lot of it. There's, of course, needing to understand phosphorylase.
Dr.
Yes?
You said for the phosphorylated regulated that PSK was one of them. But I thought we said in class that it was pyruvate kinase.
Well, no, I didn't say PFK.
No.
Pyruvate kinase, yeah. carry on.
Wait, it's not PFK because he did say.
No. He said kinase.
But right now he said PFK.
It's different. He said
She's talking about who
covalently
before?
modification. Yeah.
But it's not covalently. See, this, right? Just try to, compare and contrast. Look, right, for all the similarities and just, okay? Yeah, right, that's an aspect of the forest, isn't it? Right? So,
what about is there more regulation as we go on?
so I was talking about phosphorylase, right? So then, just get it squared away in your mind. There are all these slides about phosphorylase, right? So there's got to be at least one, if not two, questions.
When you say phosphorylase,
Glycogen phosphorylase, right? So catabolism, it's the one that binds the inorganic phosphate, right? And it's going to cleave. It's not going to hydrolyze. It's going to cleave the glycogen, right? I guess we did leave out. There's also the kinase that phosphorylates phosphorylase, right? But I looked at that and it falls into the same category also.
the PP1 protein.
Oh, that's the phosphatase. That's the reversal, right? So just anyway, so there's two ways to regulate phosphorylase, right? Generally, what's one? Just general modes. Yeah, covalent, right? Phosphorylation, and then the other. No, well, what's the effects then of the hormonal regulation, right? It's a cascade, right? And what's it going to culminate in? Phosphorylation, right? Okay. So what's the other mode, though? Allosteric, small molecules, right? So the energy charge or the glucose, depending on whether you're liver or muscle, right? So just kind of know that. Okay, what else? Is all of that, everybody squared away with that?
Is it small molecules
Like the AMP, right? Or the glucose, right? So the AMP was muscle, wasn't it? Right in the muscle, and then wasn't it glucose in the liver? Like if the liver if you have a high concentration of glucose, right, then do you want to be catabolizing your glycogen? No, right? You want to be synthesizing, right? So, seems right to me. All right, what other kind of things? Okay, is Amanda here? Amanda Wynn? Where's Amanda? Hi. Amanda, I'm sorry I didn't write back to you. Amanda sent me an email at 12:34 last night. Normally I'm up that late and I would respond to you, but somehow I had actually gone to sleep. So, okay, so Amanda asked about the names. Amanda, I hope you don't mind me. I'm just going to discourage y'all from, please feel free to write and ask about this stuff. So anyway, about the names, knowing the names for the complexes in oxidative phosphorylation, right? So, I've said, don't memorize these names. Okay, you need to know the names of the key regulatory enzymes, but say not the names of these complexes. But then I got thinking about it, and that's an excellent example of what I'm trying to get y'all to do, and that is, because your question, Amanda, wasn't it like, so one of them is an oxidoreductase and sometimes called an oxidase, or oxidoreductase sometimes called a reductase, and then the other is oxidase or just cytochrome C, or right? And I didn't know the answer. I would have had to go back to